Okay, let's start learning how to loop over a dictionary. In the previous part 4, we learned how to loop over strings, lists, tuples, and sets, but we didn't talk about dictionaries because there are a lot of things that we need to cover in this part, okay? So, iterables are strings, set, tuple, dictionaries, lists. Iterated, the keyword means we can loop over. We can visit each item they have here. But in the dictionary, it's a little bit different. We have key on the left side and value on the right side of the column. So how we can do this? Well, we can use a normal for loop. So for item, or let's say, yeah, we can say item in car dict. Remember this in keyword, very important. So let's say print item. And if I run this, I will have brand, model, year, engine, everything, okay? But these are the keys. I don't have the values. Now, if we want to get the key value pairs, we can use a method here. So this method is known as, so I'm just gonna write here for loop, but we can loop this way using the items method. And how we can do this? So I'm gonna copy this one because it's gonna use the pretty much same syntax, but instead of car dict, I'm gonna use dot items, right? And now, if we run it, let me just print so you know what's going on, okay? Okay, so I have the output here, the key and the value, but as in tuple, okay? So we have the result as tuple. Why it's tuple? Well, because of these brackets. Okay, now let's do another method, which is called values. And items method, this will be for loop. I'm doing this, guys, because I want you to know which output belongs to where, okay? This is more convenient, okay? Now, let's do this one and name it as a values method. So we're gonna use a values method and you will see what we will get as the output. Okay, so I'm gonna copy the same thing and we're gonna change the method. So instead of items, we're going to get the values. And what you think we will get? We will get the values only of this dictionary object. Good. So we have keys, we have the values, and we have keys and values if we use the items methods. Another method that we are going to do is known as a keys method. And this is no different than you will see, it will give us only the keys, but the output will be slightly different. Keys method, and let's do keys here. I'm gonna use the same. So what you think we will get back as the output? Here it is. I got the keys. So this one and the normal for loop, they're pretty much same. Now, somebody will say, well, I want both keys and values without getting a tuple back, without getting another data type. So how we can do this? Well, there is a simple trick that developers are using, and that is called unpacking, right? We know about Python unpacking and how we can do it. So let's copy this one, unpacking method. And it's not a method, right? Please don't get confused. It's not a method, but it's just like a trick that developers are using to get this one. Now, I'm going to use here items because we know that items will give us brand and model, right? But here, I'm going to create the two variables. The first one will be key and the second will be value, okay? And I will unpack whatever I got from the item. Now, if I do print key and value, what you think I will get? Let's see. There you go. I have a brand, I have the key, I have the value, and that's what we need. So I unpacked whatever this return into these two values. And we know that it was returning this one, right? A tuple. So this is how we can unpack the values. By the way, this key and value can be even K and V, but make sure you use them here, K and V. Doesn't have to, you can name this variable whatever you want, okay? Please make sure that you know that. There you go, you have the same one. But I like to have a more descriptive names so everyone can follow me. Now, another way we can do this, we can grab both keys and values. If we use the previous for syntax, like this, but change it a little bit, how we can do this, okay? For loop, updated syntax. Okay, now instead of getting here the item, I will write key and value, right, like this. And from car.dict.items, right? And now I can just print the key and value. So I have done the unpacking up there, okay? And let's see. There you go. Now you know how you can get everything from a dictionary, how we can loop through all of the values, how we can get the keys, how we can get the values. So if you need only the keys, you will use the keys method. If you need the values only, you will use the values only. But if you need both of them, without getting a tuple, you don't need to use the items method like this, but you can just change a little bit the syntax, okay? So I hope you learn how we can loop over or iterate. That's another keyword that you should remember. So how we can iterate over an iterable, because iterable are these guys here. Okay, maybe we should do this so you can it will be more clear for you guys. Okay, so these are the iterables because they have items inside, so we can iterate or loop over. There you go. Now we are going to continue with the built-in range function. This will be very good. Okay, let's talk about the range function and how this function can be used in conjunction with loops. Okay, so we talked about range function before, we have used it, and let me just zoom this one maximum. So range function have a start, stop, and step. Okay, it takes 3 arguments. The first one is a start index and it's optional. The stop index is where we need to stop, for example, from 0 to 10, and the step is step over. Okay, what's the size of the step? So we have done it before. I'm not going to just cover the same one, but we are going to learn how we can use this range function that is very popular together with loops. So we can do it here straight in the loop. So for number in range, and here I'm going to pass the 2 parameters, right? The first one will be start, stop, then colon here, and I'm going to say print number. If I run it, now I have the power or ability to loop over these numbers. How cool is this? I don't have to create a separate variable here to say, okay, this is the range, then go from 0 to this. And this range is very, very useful. Now, sometimes you don't even need to specify the variable. So you can do underscore here and use that underscore here. And again, you will have the same result. Okay, so now I hope that you can understand why this range is so important. Okay, lastly, I want to include the step over. For example, you need something like this, and you will see that we have 0, 2, 4, 6, and 8. So the step over is the last parameter, and that one is optional. By default, it's 1. So if you don't specify, it's gonna be 1. And that is pretty much it. Now, I'm just gonna copy this one here, and I'm gonna comment this part. Oh, I'm not gonna comment actually, but I'm gonna do it without this and number, so you can have the both versions with it. Okay, good. Now you know how to use this range function in conjunction with loops. Enumerate. Enumerate function, similar to the range function, will take a collection and will return an enumerate object. And this is pretty much confusing for some of you, but after we cover the first example, it will be easier. So this function will take as a parameter a tuple, for example, and it will return an enumerate object. Let's create a tuple here, and tuple should be x in brackets for the tuple, and say 1. We can have whatever we want, so I just want to make my lab easier. Okay, now as I said, let's create a variable. Okay, first talk about the enumerate. Now this function will take a collection like a tuple, so we can pass the x there, right? And we can store that back into the variable y. So if we print this y, we will get an enumerate object. But why all of this? Why we need all of this? Well, look at this. I'm just going to comment this one, right? We don't need it because now what we can do, this function will also give an access to a counter or index as the key. So here we have 1, 2, 3, but we don't have the indexes, right? Like in the lists. But this function, when it creates this, create this enumerate object, will give us access to those keys, to those indexes as keys. So I know this is confusing, but you can see it right away. So for item in y, right, we can print the item. Now you will see that this enumerate object will return again a tuple, right? But I have access to the indexes. How cool is this? So again, enumerate function will take an iterable as a parameter, and it will return an object with an index, which is the key. Now the tuple have access to their indexes, just like we have the same one in list. And instead of doing this, we can do this now. For key and item, I can just put here key and item. And now if I run it, the second example I will have, let me just comment this one part. And I should have this one, okay? Why I didn't see the first time output, I have no idea, okay? No, maybe it wasn't saved. Now, excellent. We got back not just the value of the collection, but the indexes as well. We can do the same thing for strings as well, okay? Not for the tuples only, strings, and put here tuple. So the enumerate will get as a parameter or as a argument can take a iterable, a collection. Okay, so we can do the same for strings. So let's do this one straight in the for loop. Okay, so for key and item in enumerate, here I'm gonna pass the entire function instead of doing this. Okay, it's the same, but I've done this just to show you how it works. Okay, but you can do the same thing like this. So I'm gonna say Rick here and colon, don't forget the colon, and print the key, the key and the item. Now let's do this and see if I have all of this. Here it is. I have all of the characters from the string together with their indexes, and this is very powerful. Now we can do the same thing for lists. Let's just change this to list, and here instead of doing this, I'm just gonna create 1, 2, 3, 4, and yeah, so I passed the list there. Now I should have 0, 1, 1, 2, 2, 3, and there you go. Excellent. This is how we can use enumerate function. This is very useful because not only we can iterate over the values, we can have the access to their indexes as well. Let's learn about break, continue, and pass statements. Okay, these are all statements, but they're different from each other, And we already saw the power of break, but we're going to use it again. Now here I have a list of 1, 2, 3, 4, 5 car brand names, okay? And here I'm doing a basic loop, okay? So I'm accessing each entire item from this car brands list. Now, the break, if we use the break, we're gonna break the entire loop. So for example, I want to break when I reach this item Audi. So if I do if brand is equal to Audi, then I want to break. Now the break, what it will do, it will break from this loop and it will go outside here. Okay, so if I run it here, I will not be able to see Mercedes and Volvo, right? Because I broke the loop. I said, okay, when I got this one, just break the entire loop. Don't go back, just go continue working with the rest of the code. So that is the power of the break. So the break is very useful because sometimes we don't need to loop over all of the elements. When we find an element, just gonna break it, okay? Now, that's a break statement. Okay, so I'm just gonna print here and let's do this, break. And there you go. Now I will have another called continue. Now the continue statement is very different from the break. Why? For example, let's do if brand is Audi, just continue here. Now the continue will not break from this loop and go straight here, but it will break from the current iteration. So when the Audi, that's the current iteration, will say when it reaches this line, continue, the interpreter will not print this one, it will go straight here again to do another loop, okay? So it just skips that iteration. So it's gonna break the current iteration, but not the entire loop. Okay, so ideally when we do this, we're not gonna see Audi printed, but each and every item from this list will be printed except Audi. Let's test this theory. Here it is, BMW, Tesla, there is a Mercedes, there is no Audi here, right? And outside the loop. There you go. Now the last one, the last statement is called a pass statement. And I'm just gonna copy entire thing here. Now pass statement, it's very different than this one, okay? So for example, I'm not gonna use it actually this, because it's not applicable. So the pass statement is used as a placeholder for future code. What does this mean? Let's create a variable is old here, and that will equal to true, and say if is old, and which will be true, we need to go inside, right? We set the condition to always be true. That's why we need to go inside here. But here at the moment, I don't have code. I don't need to write a code. I just need to create this if condition because in future I'm gonna add it. I'm gonna expand this if. So here I'm gonna write pass and that's it. There you go. Now if I run it, I will see outside the loop, outside the if statement, okay? Let's run it again. Let's zoom this one here. So outside the if statement. Now, the pass is used to be as a placeholder for future code, but if we don't have pass here, let's comment this one and say pass, and yeah, we don't write anything here, okay? So what will happen if we run the code like this? So here we say indentation error expected at the indented block, because now at this moment, we don't have anything in the if body, because this is the block. It starts from here and it's end here, right? This is the entire if block, but we don't have anything in the body. So because we need to write something in order to avoid this indentation error. And with the pass statement, we can do that because the pass means, okay, I in future will add code here, right? And that is making our program without crashing. So our program will not crash because of this pass. Now let's summarize. Break When we use break, it will break out from the entire loop. It can be used even with if statements. We saw that, right? Now, when we use continue, it will continue the current iteration, not the entire loop, because only this part will break and it will go back again. So it's not going outside, right? And the pass is used as a placeholder for future code. Okay, ladies and gentlemen, I think we learned a lot, and now it's a practice time. So we have learned about loops, conditionals, operators, and a lot of other things. Okay, now the exercise here is that I have a dirty list, and the dirty list is is a list that have duplicates of values. Now your goal is to create a clean list, and you can name it clean list, but you can name it whatever you want. And and that clean list will not have any duplicate values. So here I'm giving you 2 tips, and I want you to pause the video and attempt to work on the solution. But if you can just watch me. Now, so you can use one of the membership operators, okay? And I'm just right here, solution 1, using membership operators, and one of the membership operator was not in. Okay, so we can use that one. So first things first, I'm gonna create a clean list, an empty list. Then I can loop over the dirty list. And by the way, outside, I'm living in a house near the street, so people are driving very crazy here in Australia. Yeah, and not good. Sometimes you can hear them. I'm so sorry. There is no way to block them. They have V8 machines, very powerful. Okay, so for item in dirty list, let's check first if the items will be there. Print item. Okay, now if I run it, I should be able to see all of the values, all of the items. Good, it's working. So the goal here is to check if this item that I have in the current iteration is not in clean list. At the beginning, clean list is empty, right? But if it's not there, so it will check, okay, this list is empty, then what it means, now we can do clean list.append. You use this method to add that item. Good. So that's pretty much it. I can just now mark this one here, and there you go. Now the last part is to print the clean list. Let's see if it's gonna work. Here we go. 1, 2, 3. I have 4. Okay, it's not ordered, but doesn't matter. So it's not ordered, but there's no duplicates of values. All right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Nice. The second part is to use the built-in functions and convert the list to a particular data type. Now, solution 2. So remember that the sets, they are a data type that doesn't allow duplications of values. So we can use that. We can create here clean list, or let's say clean set here. And this set will be set the built-in function, and we're gonna pass the dirty list. Now, if I print the clean set, I should see a set here that is without any problems. And here, by the way, it's ordered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now, I can create a clean list. Again, clean list. And I can use the list built-in function and pass as an argument this one, right? So what I essentially have done, I've converted the list to set, and by converting it, I cleaned the dirty values, and now I need to get that set and convert it back to a list. How clever is this? Clean set, not like that, and print the clean list. By the way, we don't need this one anymore. Oh, we can stay it just to see that it's working. There you go. Now, by the way, this one is ordered, okay? Now, I want you to find a way. I'm not gonna give you the answer I want you to find a way, you can Google it even, how to order a list, okay? That's it, this is the practice time, I hope you like it. So you've managed to create a clean list out of this dirty list. Okay, now let's discuss about Python functions, function arguments, and parameters. We already have discussed about these things, but not in detail. So we have used functions so far, and these are the built-in functions, right? But in this lecture, we are actually going to write the functions. And here are the key terms that you need to learn. So function declaration, function call, function parameters, or function arguments. Okay, so how we are define a function, how we can define a function, okay? So diff, and here goes the function name, hi function, then this, and here print hi there. Now, what we have done, so we use this keyword for defining a function. So this is called function declaration. Then the function name, this can be any name you want. But remember, when you create a function, you need to use these brackets. Then colon, and here goes the function body. The function body can have multiple statements or a single statement. Doesn't matter what, you need to do it with the indentation. So outside here, it's a different story. Outside this means that these statements we're gonna write here without indentation, they don't belong in the body. So same as the for loop, same as the if statement, okay? So we need to use indentation. Great. Now if I run this, I don't have any output. Why is this? Well, the functions needs to be called in order to be executed. So how are we gonna do this? Well, we need to call the function outside the body. Let's give a breathing space and type here, call the function. And we can do that by using the function name and include this bracket. So now if I run it, I will see the body of the function. Cool. So we learned about function declaration. This is how we declare a function. This is how we call the function, or it's also called function invocation, or how we can invoke the function, okay? Nice. Or invoke the function. We don't have to write it this, right? You have here. Okay, nice. So somebody will ask me what will happen if I don't use the brackets. Well, let's do it. If I don't use the brackets, will I have an error? Let's see. And yep, it doesn't give me anything. But what we can do is actually, you can use the print here, right? Let me show you. Oops. Print hi function. Now if I run it, I will have a function, hi function, that is sitting in this location. So it will give me where this function lives. It will give me the function location. So that's pretty much it. That's why we always need to use these brackets, because we want to execute this function. We want to call this function. We want to execute this function, okay? If we don't use the brackets, then we're gonna have the function function location. So this hi function is stored somewhere at this location. Okay, now, so now you know that always when you want to call the function, you need to use the brackets. Now, another thing, you cannot call the function before it's been declared. Now, let's do this. Let's comment this one. So I'm calling the function before it's declared, and if I run it, I will have name error. The name hi function, this one here, it's not even defined. Well, because it goes from top until bottom, the interpreter goes here. So these are the comments, it will not do anything, but this is the function. So it looks for this function up here, up there, but it's nothing there. And that's why we cannot call the function before the function is created. okay? So I'm just gonna zoom, comment this one and comment this one. Now you know three things that you can't. Now you know three things. You know how to write the function, you know how to call the function, and you know that you can't call the function before it's been declared. Good. Now another two things: function arguments. Let's say arguments and parameters. What are these? Now the functions we have created so far, this one, it's very simple. So the function can take multiple parameters here. I will show you. I'm just going to copy this one and I'm going to name it hi function1, and here I'm going to say name and last name. Okay? Now these two are function parameters. So we can use these parameters and access them here. Actually, I'm going to use the formatted string here, f string, and I'm going to say hi there, name. Remember, when we use the formatted string, we need to use these curly brackets in order to access the variables. Consider this as a variables that are local for this function. Last name. So I cannot use these variables outside here because they're called function parameters, right? Maybe I should change this to parameters and arguments because I started with parameters, okay? Nice. So the name and the last name are parameters, and now we need to call the function hi function1. And here we need to pass the arguments. Now we have two here parameters, so that means that we need to pass two arguments here. Now it can be even one without comma, right? If we need only one, then you don't need the comma. But if you have multiple parameters, then you need comma. You can have three more, how many you want. Okay. Now hi function1, we can pass these two parameters. Say Rick and like this. So if I run it now, I should be able to see hi there Rick Sokolowski. That's my name. Okay. Now these arguments can be name, can come from a variable named Rick. Let's change it to Jason, and last name could be anything you want. And by the way, this can be name1 and name2. These are, don't confuse with this, it's not the same. And Jason Momoa. And instead of here passing like this, I can just do another function call, and this is important. You can call the function as many times you want. Name1 and pass name, last name 2. Okay, now I've used these two variables here, and don't confuse this with this, right? These are just names. It can be N and L, and here N and L, right? So here it's what is important. We are passing the arguments. Now you know that when we are declaring the function, we have parameters, and when we are calling the function, we have the arguments. And the beauty of the function, here it is. We can call this function with different arguments because the function body have this line, or the function is created in that way that can be called multiple times. And that is the goal for the function. The goal for the function is the function to be run as many times as we need with different parameters, because we know what the function will do, and the goal of the function is to produce the result. We will see we can create much more complex functions than this. This is just the beginning, but now you know about function parameters and arguments. The parameters goes here, and it can be 0 like this, like this, or it can be 1 or many. If there are many with comma, we can access them here like this, but we cannot access them outside the body, right? And these are the way how we can call the function. We can call the function directly supplying the arguments like this, strings, or maybe they can come from a variables. We can pass here even a list, right? Let's create def function, okay, let's say calc fun, and here I will have a list or num list like this, okay? And inside this num list, imagine that this is a list with numbers. I can do a calculation. Sum list is equal to 0, right? And here I will say for item in num list, I will do sum list equal to or plus equal to item. Good. And at the end, I will say return sum list. Or I can say print the sum list, whatever. We can use, we don't need to use the return because we haven't talked about that one. Okay. Now I actually need to call this function using the, let's create first the list, num list. And let's do 1, 2, and 3. And the result will be 6, right? So 1 plus 2 plus 3 is 6. So the only thing that's left is to call the function with this num list. And if I run it now, I should be able to see 6. There you go. Now I can call this function with another list if I want. I have 4, and let's do another function call with this list here. So I will have 6 and 10, right? Because this will give you 10, and there you go. So the idea is to create a function that can be used multiple times. And we're not gonna write the same code over and over again. Look how clean it is. We have the code in one function and we can reuse it for different lists. So this is called dry principle. Do not, dry means do not repeat yourself. Okay, this is a very important principle. And that's what the functions do. We do not repeat the code over and over to do the same calculation. There you go. Now you have learned a lot about functions. I hope you understand. The main point is to know how to create a function, know how to call it a function. Don't call it before it's being created. Now, these are called parameters and these are called arguments, because here the function have 2 parameters. We need to pass 2 arguments here, and we can pass it like this straight away, or they can be stored in a variable and then use it here. Now we have created a calculation function that will take a list as a parameter, and here's the list, and then we pass that list. Actually, we can call this n list, right? Just not to confuse you, because these are different things, and here change it to n list. Okay, there you go. So these and these names should not be confused. You can put any name you want here, okay? And there you go. Now we can call the function. So I hope you like it. In the next section, we're going to learn more about functions because we are not done yet. Okay, let's discuss about positional and keyword arguments. We already learned what arguments are, but we have 2 different types. So first I'm going to create a function called display details. So define function called display details, and this function will take 3 parameters: name, last name, or L name. Let's do it here: name, L name, and age. Okay, good. Now what we can do is we can use the print and the formatted string f. So hi there, and I'm going to say name, last, L name, sorry, not last name, L name, dot, are you, age, years old, and question mark. Okay, now we can call this function right away. So display details, and pass here Rick Siklowski and age, for example, 33, and let's run it. There you go. Hi there, Rick Siklowski, are you 33 years old? Everything is working, but what are the positional? We start with the positional arguments. Now, arguments, if I can type it. Now, positional arguments are very important because their position or the order is very important. Why I'm saying it's very important? Well, look, if I change the order, from this, I'm going to call it again. So if I change the order from this to this, don't forget the commas, and if I run it, the output will not be meaningful at all because, hi there, Rick 33, are you Sekulowski years old? The output is rubbish. So that's why the positional arguments, their order is very important. And we cannot play with the order if we want to have the right output. Good. Now you know about positional arguments. So what about the keyword arguments? Well, the keyword arguments are labeled arguments. We can put a label there. And how we are putting a label, I'm just going to copy this one. I'm just going to say here, and I'm going to give it a name equal Rick. Sekulowski should be L name. Remember, I'm using the same parameter names for their labels. So this is how we create the labels, and age. Now if I run it, this third output should be correct. So the keyword arguments, they have their own labels, but their order is not important. Not like the positional arguments. So I can do this. This gives me the power that if I remove this here, put it there, oops, I should be able to see the exact same result. Here it is. Hi there. Are you 33 years old? Nothing changed, but I changed the order. This is because of their labels, and their labels should match the parameter names. So for example, if I say last name, if I run it, there you go. An expected keyword argument. Nice. So now you know about keyword arguments and positional arguments. Okay, now we're going to talk about default parameters. We saw that in the previous lecture about the keyword arguments and positional arguments. But default parameters is something that we can create, and default parameter will allow us to give default values to the parameters. How is this possible? Well, same as the named arguments here, we can have default parameters. And here I'm going to say John. Here I say Doe, age 30. Right. Now, if I call it like this, the default parameters will never be used because Rick will be changed here. Sekulowski will go for the last name, and the age will override this 30H will go here. But the beauty is if I can call this one without any parameters, within any arguments, now the default value will be used. Good. And even if I do this, even if I miss the last age, so even if I don't do this, right? Now I will have Rick Sekulowski, and the age will come from the default value. Good. Here it is, 30 years old. I hope you now understand how these default parameters can be used and how we can give the default values. Now, every time we use the total number of arguments, these default values will be overwritten. Okay? That's pretty much it. So I hope you understand now how the default parameters can be used in a function declaration. Okay, now it's time to talk about function return. So probably you saw me in one of the previous lectures. I've used the return keyword instead of print, and I then delete it, and that keyword return is a special for Python, and it's used in functions because the goal of the function is to return something, to produce an output. So let's create a function that will do a basic calculation. Now, there are functions built in Python that will do this calculation, but let's write it our own. So calc function that will take two parameters, num1 and num2. Well, let's say num n1 and n2, right? And this n1 plus n2, so far we have used this syntax. So we were printing, let's say here sum num, and we were printing the nnum and n2 and print some num, right? Now when we call the function, let's pass 5 and 6. This should return us, this should print actually 11. But now with the return, we can just skip this whole thing. So we can do this. Return keyword, if I can type it right. And I don't need the print. Now, one important thing is that when I use return n1 and n2, so if I call the function like this, it's a valid call, but it's not gonna give us result. Why? Well, this function call with these two arguments will produce result. The result will be returned, but we never call it. So we can say print here, and now we will have the output of 11. Good. One other way how you can do it is gonna say result, create a variable and store there, and after that you can print the result. Okay? So this is the power of return. Now if I add +1 here, it will be 12. I can do whatever I want with this variable now because I've stored the result. Now, one more thing. After the return, if I do print hi, should give me a warning, but it didn't. So what you think will happen? Nothing, because when this line is processed by the interpreter, this whole function is done, goes here. The lines or the code after the return keyword, it will never be executed, okay? So make sure that you don't write any code after the return. So when you return, that's it. The function is done. So this is very powerful keyword for Python. And the goal of, remember, the goal of the function is always to return a value. And we can store that value like in the result, and we can modify that value if we want. Whatever we want, it's there. How cool is this? So that is all about function return. In this lecture, we're going to talk about nested functions. That's a function within a function, or the similar scenario that we did with nested for loops and nested if statements. Okay, so let's create these functions. So I'm going to use two functions here. The first function is going to be called outer function. And this function will take two parameters, num1 and num2. Now, colon here, and inside, look at the indentation. We should give proper indentation. So we're going to define another function called inner function. And this inner function will take two parameters as well, n1 and n2. And what this function will do is will simply return their sum, right? So if we pass here 1 and 2, it will return 1 plus 2. That will be equal 3. Okay, now we need to call this function. So we are done with this function. So we need to call this function, but outside of the function of the inner function body. So that's why we need to call it here. Or this is in the same level, or we are in the body of the outer function. You can see the line here, okay? This is inner function body, and this is outer function body. So we're calling this inner function with these two parameters, num1 and num2. Now, great, because when we call it like this, for example, we pass here 1 and 2, it will be 1 and 2, and it will return the result. But because we know that this will return a value, we need to store it somewhere. So I'm going to say total here equal that. So now in the outer function, I have a total variable that will have the value of this function because we are calling it here. And at the end, in the outer function body, I'm just going to return the total. That's it. Now let's call this outer function with 1 and 3, right? Now, what will happen? 1 will have num1 and 3 will be num2. So inside here, this function will not be called immediately, right? So it will go here, total equal, and now the inner function call is initiated. So we're calling the inner function. And here we are setting 1 and 3. Then it goes back to step number 3, and it's the parameters n1 becomes 1, and the parameter n2 becomes 2. Then in the return 1 plus 3, it will be equal to 4. This function is finished. The result is returned here from this function, and it will be stored in the total variable. Now, the step 6, the interpreter will say, okay, I have the total have 4 inside. I'm just going to return the total. And we can do print here straight away, or we can just we can create another variable result that will have the value, whatever returns this one, and this one returns the total. So print result. We should have 4. There you go. So this inner function was called in the body of the outer function with their arguments. And arguments are 1 and 3, they become parameters here, and also they become the same parameters for the inner function. Okay? So the interpreter will go here. First, we will create the outer function, right? So it will go here, it will say, okay, this is a definition of the function. I will not run it because someone needs to call it. It comes to line 8, and there is the actual outer function call with 2 values. Then goes back to line 2, then goes to line 3 and say, okay, this is a function definition, no one calls it. I'm going to line 5 because 4 is inside the body, right? It will go into line 5 and it will just call the function with 1 and 3, goes back to line 3, process the sum in the line 4, then breaks out of this function, store the result for here in the total, and then the line 6 will happen. It will return the total, then it goes here again, it will store the 4 to line to 8, and the print will go. So that is the steps, okay? So there you have it. Now you know how these nested functions are working. Okay, let's talk about docstrings in Python. Oh, my REPL is complaining something. Yeah, it's connected now. So docstrings in Python. So the docstrings in Python are string literals that appear after the definition of a function or a class or method or even a module. So we haven't done classes modules, but yeah, that's it. So this is how we write a string literal. We use triple quotation here and we close it. Now if I run it, you will not see that literal, okay? So let's create a function called num square, and this function will calculate the square of a number. So I'm gonna say definition here, define num square, and here I'm gonna pass one parameter called n1, and I'm gonna return n1, and I'm gonna use the operator we already know, okay? So I'm gonna say result, I'm gonna store the result of this function, num square, and pass it for here and print the result. And run it, and I should get 16 because the power, yeah, good. Now we have the 16. So what about the docstrings, okay? So we can write the docstrings like this here. Don't forget the triple quotation marks and say this function, you can say whatever you want here. This function takes a number and returns the square of that number. Takes a number as parameter and returns the square of that number. Cool. So this is a short description of what this function does, but even if I run it now, I will not be able to see it. So how I can see this message here? It's basically a message. So I'm going to use the built-in help function, right? And call the num square like this. And I misspelled it, right? So if I run it, here it is. This function takes a number as a parameter and returns the square of that number. So why we need these docstrings? Well, imagine that you're working in a team and you have a lot of functions there doing different things. So you write a comment like this, and instead of the other people or the other developers or programmers working with you joined that recently, Instead of they going through the documentation to read whatever your function num squared does, oh, by the way, it's obvious, but they're gonna use this and they're gonna read it. How simple is that? Now, there's another way, and this one is not working currently. So if you hover on this function with your mouse, and I don't know why it's not doing it, it should have a window. It should pop up a window here saying, okay, this function is doing this and that. Okay? So there's another way even how we can find the docstring. So I'm gonna use the help again. And for this, I'm going to use something that is called dunder method. And dunder method in Python are magic methods. So yeah, they're called special methods and they start and end with double score. Okay, we're gonna talk about more about them, but they're very special methods, right? Because they start with double underscore and they end with double underscore. So I'm just gonna comment this part. Now if I run it, okay, no Python documentation, but here it is, right? The description. Good. So to summarize, the docstrings are the comments that we want other programmers to see. These comments should be meaningful and explain what the function does. We can use docstring not just with the functions. I explained with the methods. I explained that we can do it with modules and classes. But for that, we're going to learn it how to do it in future. And this is it for part 5. And we are not done with functions. We're going to learn a couple of more things. But I promise the part 6 will be super, super awesome. So please make sure that you go there. And if you don't understand something, just you can always watch it again. So as always, please share, subscribe, like, whatever you do with this. And I hope I'm going to see you in the part 6.